Hello everyone, is the probe completed? Uh, let's see if we get a bit more focused. How's that? Yeah, that's better. I've got a ground lead on mine, and I'll show you the reason for that in a moment. But I've got me bit of wire on the end for probing as well, and the battery's in. Let's see if we can see the light, because I wanna get that on camera. I just want to try and show you that it's actually flashing, because I've actually I've made the frequency very low for this, because I'm going to use it in a different way, and I will show you what I will be using it for. Like I say, I don't do amplifiers or any sound type of projects. Like I say, I just mess around with microcontrollers. So yeah, let me just set up my oscilloscope. Oh, and also once I've set my oscilloscope up, I want to do an experiment first and just show you a probe, no battery, nothing, no components, nothing, just a wire and a bit of tin foil. Yeah, right, won't keep you waiting. Right, okay, I mentioned in my last video about noise on the bench around here. I've got a lot of noise on my bench. Like I say, I'm just doing projects. It's not a proper bench, workbench. It's not earthed, not grounded, anything like that. It's just where I just do my projects. So I've basically got a lot of noise. I've got a bench, and actually it's got a glass top. I don't know if you can see that, but if I put my hand underneath, there's a glass top. If where are we? Pointing down here, look, you can see my hand underneath. That's because I can put my tools underneath, and there's also underneath here is my there we go. Underneath here is my power supply, my bench power supply. I have a glass top because I can put things underneath and I can see what I'm reaching for. Okay, so that said, and what I've said is that this uses very little power, because I was wanted it to work with one of these little tiny batteries, and because it uses very little power, it can pick up noise around the thing. So if I just connect my oscilloscope to it, actually let me let go as well, because right, I just need to let go of it as well. Right, because I am a big sodding aerial as well, you know, so yeah, I think if I grab it like that, it's not so bad. But can you see that it's picking up 50 hertz? Well, that's 50 hertz from my mains, and it's picking it up like an antenna. And if I grab it, so obviously this needs to be put into a plastic case, because basically if I grab it, you can see that it totally increases the power output. This is not an issue for me, because using this, if I take the ground lead and I fasten the ground lead to what I'm working on, which I will be, then we've got a grounded circuit, and you know, the current can flow through the ground. So even if I touch it, it's not really an issue. And if I now press the button, there you can see that I've got an 18.6, 18.7. I was aiming for 20 hertz basically, and that's the closest I could get using the standard capacitors and resistors, and I was trying to get a 50 50% duty cycle. Oh, that's what I forgot to put up there, is duty. Yeah, I knew I'd forgotten to put some up. Let me come back to this. Let me modify my oscilloscope. Right, just added that. So when I press the button, now we should see what this is 18.75, and I tried to get a 50% duty cycle, but I'm getting about 54. It's all to do with changing the resistors and capacitor. Let me just bring up my circuit. I've put some notes on my circuit. Right, here's the circuit. The timer's in astable operation. After I could never forget. I could never remember the word, so I put it in big letters. But yes, so I've changed these. These two resistors and this capacitor. I've now got a 22k here for R1 and a 100k for R2. The ratio between these, basically you've got a total resistance between these two resistors, and then you've got a ratio between the two. So this is like I don't know, 1/5. Is it 1/5 of that? Sort of around that. I can't do it. It's if we made it 20k, it'd be 1/5. So you know that gives that ratio there is giving us our duty, which can't bring the thing up because I haven't got it turned on. Right, so that brings the duty, and then obviously then you got the two resistors and the capacitor to calculate your frequency. So I've put some notes down here, and basically what I'm going for is this 330 nanofarad, which is like a standard capacitor. So that will give me that 18. If I wanted 20, where have I put it there? 20, I would need 324. So the 330 is the closest. I've put a little bit of chart here. So if you wanted to use it like for the audio and have a nice high frequency, you can put 1 kilohertz using a 6.5 nanofarad or whatever's close to that. And that'll alter the frequency. So these are the frequencies down here that I changed. But I wanted a low one. Basically, I wanted a low frequency down at either 2, 10, or 5, so that I can watch it and count it in my head. So I can actually see 1K. You're not going to see the LED flash, or this, you're not going to visually see it yourself. So, because I'm going to use this for a completely different thing to what Richard's challenge was. It'll still work in a challenge, but I just wanted to point out that I am going to do something different. So let me just go back to the my bench. Yeah, so I just wanted to point out that when you're using something like this, sorry, I got something in my throat. When we're using something like this, you've got to be aware of your environment that's around you. Like if I remove the ground, so this isn't grounded out, then it's going to pick up a lot of noise from the area around you. And also yourself is a conduit of electricity. So if I grab it, then you can see that the signal is amplified as well. So if I'm using this just to probe around without the ground on, you're going to get a lot of noise anyway. This here is to my auxiliary on my computer. So if I, without the ground and without pressing the button, you've got the hum. You recognise that hum. I don't know if you come out, but basically that hum is what you get just from yourself and the surrounding area, picking up the stray signals. So that's without the button pressed, and also so we're going to try it with the button pressed and no ground this time. no ground, but with the button pressed you'll see that, should see the light. Or can you see the light? Oh yeah, you can sort of see the light. So this time I put it on and I'll press the button, and you can hear the actual signal, and that's a recognisable signal. That's at 17 hertz, 18 hertz. So it's not quite as bad, but you can see on the oscilloscope that we've got the ambient noise, which would you picking up from yourself and your static in the area around you. So I just wanted you to be aware that not having things grounded, you can be picking anything up from anywhere, and that is what actually threw me last time. Well, the fact that I hadn't on my prototype, I hadn't actually connected. I haven't actually turned the timer on. It was the static around me that was actually turning the timer on. So yeah, so now I know of that issue, but you can see me touching it and you can see everything going on. So just get ready for a bit of louder noise. What I'm going to, what you can, just so that you know the difference. So with the without the ground, we've got that noise. It's recognisable, but if you put the ground on also, I'll just put the ground on here. I've got ground connected to everything. All my stuff, I've got USB and everything's linked. And so now what you'll notice that the home's gone because we're now grounded, and it's not picking up the stray signals. And what I'll do is I'll just press the button, but it's going to be loud, so just be warned. Bit like a machine gun there. Right, okay, so I'm gonna, we can forget the audio side of things now, because I'm not doing that. What I wanted, oh yeah, actually before I continue, what I wanted to show you was, I was talking about the static and the signals around you. Let's just bring that back. Yeah, so let's have a probe without any batteries, leads or anything. So here's a bit of tin foil. This is just tin foil. I've stuck it down a piece of tube, so that's a bit of plastic tube. Let's get that all the way in. Bent it over. Right, so there's some a tube with a bit of tin foil in, so I'm insulated from the tubes, whatever we're probing. And we get a bit of bent wire. There's a bit of bent wire. Stick that in the end to give us our probe. So I'll put that in there and bend it over the bit of tin foil. And there we go. A probe, no batteries or anything, it's just a bit of tin foil, picks up the static from your hand, and you can probe. Let me just get the probe off this oscilloscope. Let's put the probe on the oscilloscope, shall we? And there you go. I'm picking up my 50 hertz. Put my hand a bit closer to it. There we go, got a bit more. And of course you could hear the, have I turned that on? Damn. Oh, have I got it grounded? Oh, I've got something grounded. Well, you can hear the hum when my hand's on it, but oh, hang on, I don't think it'll work with the oscilloscope on it. After all, we just pick it up very minute. I don't know if you can hear that buzz, but it's a very slight hum of oh, there we go. it's the 50 hertz picking up. Yeah, I mean, it's just a joke, guys. Just a joke. A bit of tin foil picking up the 50 hertz from around the area and sticking it out on the probe. No batteries needed. Well, there was a film, wasn't there? Yeah, was it a film? Oh, no batteries included, or batteries included? I can't remember. But there isn't any batteries in that one there. So there you go. Just a bit of static from your hands and just probing. Anyways, enough of that shit. I just thought it would be a nice, cool, funny idea. Some might find it humorous, I don't know. Right, so I finished with the hum. Let me just turn that off so it might stop it from humming. Right, so I've turned that off. Yes, so I just wanted to show you why I want the low frequency and what I would be using it for. And that's why I need the ground. So what I've set up is this is just a power supply to knock, because the stepper runs on about 10 volts. Oh, hang on, mate, you can't see that. I've got the oscilloscope in the right place. Let me just get rid of that. There we go. Actually, that's better. Yeah, that's not too bad. I wonder if is it better like that dark? Right, yeah. I want you to see the actual stepper, so I'm going to leave it at that. And I've put this bit of stuff. Oh, this is the stuff that I was on about. What I put on I made the mounts for the battery on. Is this stuff? I keep it for doing some well, typically something like that. It's brass and it's coated in solder, so it comes useful for when you want some heavy soldered stuff. Right, so this bit here is just the power supply. Yeah, what was I saying? Yeah, the stepper runs on 10 volts. So I've got it connected up here with my power supply with 10 volts, but I'm knocking it down to 3 volts here, because the logic on the actual stepper driver runs at so like 2 to 5 volts. So this is just dropping the voltage down from 10 to 3 volts. So I can run the logic on here, and then obviously we've got the 10 volts going through and feeding the driver for the stepper motor. And yes, so this is just like a typical setup that I would be using. I'll just turn it on. So the motor's on now. It should be actually held in place and it won't move by the driver. But I just want to check if the driver actually is working and the stepper motors are working. Or I might have some sort of robot or plotter or something set up, and I want to move things somewhere and turn this stepper motor. Well, now I've got this probe. And it sends a square wave at sort of 18 hertz. So it'll do us like 18 pulses every minute. So if I connect my ground to the ground, the common ground, and I can probe the. I want you to watch this stepper motor. I can probe here on the one of the inputs, and I'll try and hold it so we might be able to see the light flash, and we should also see the stepper move. So here we go. Let's give it a try, and there we go. I'm now moving the stepper motor. And this is the sort of thing that I would be using it for, is to actually test logic circuits or circuits that need pulsing and what have you. I could use it on a counter, so I could probably just step the counter forward so many pulses. But that's why I wanted something with a low frequency and actually be able to do stuff like this with it. And that's cool, I thought. So yeah, it's all working just as I planned. Yeah, Yeah, as if anything works as I planned. Yeah, but it's doing it, and you can see that the LED is flashing as well. Well, it's a bit out of sync with the shutter speed of the camera, but it's actually flashing at the same pulse rate. That you can see this pulsing, and the light is pulsing at the same rate. Well, actually, that's a bit out of sync with the camera's shutter as well. So that might not look like a steady rotation, but it is pulsing round at 18 pulses per minute, sort of thing. Yeah. So yeah, I hope you like that, guys, and you understand the use that I'm putting it to. So if you watched it to the end, thanks for watching, and I hope you found some things useful.